Oh, there you are. I was about to start without you. I'm glad that you made it. Today's study on mathematics is going to determine that mathematics is just like a foreign language. I'm going to use a favorite theorem of mine from first course in plane geometry. I'm not going to prove it, and I'm not going to expect that you'll be able to prove it when we're through. When I first read it, you're going to wonder, what in the world does it say? It's as if it were a foreign language. Then we'll look at the words, see what they mean, and in 5 or 10 minutes you'll have a good concept of what the theorem says. The proof is much easier to do when one thoroughly understands what it says. Galileo recognized that mathematics was a language. He said, mathematics is the language that God used to write the universe. The study of any language involves two main components, vocabulary and grammar. Today's discussion is going to only address the vocabulary. The rules, grammar, are just as important, but they'll be addressed another day. A lot of languages have cognates, words that sound alike with other languages. German, for example, es ist warm sounds a lot like English, it is warm. And so it is with math. Today we're going to be talking about segments, and already you have a good concept of what a segment is. However, big problems can occur because the same word in a math context is totally different than usual. For example, integration. Often it's referred to racial relationships, but if a mathematician is talking about integration, he's referring to the area under a curve. So one has to be very careful to understand the math meaning of the words. In this theorem, we're going to use the meaning for altitude, which has nothing to do with elevations. After we discuss the words might be giving difficulty in understanding, you'll have a much clearer picture of what we're talking about. And once you understand the math meanings of the words, it's a quite easy thing then to prove the theorem. You will have to remember, of course, recent lessons in similar triangles, and it has quite a few new words in it also. You'll be surprised how many words there are to learn. Google Math Dictionary. You'll be surprised how many pages that takes up. Here's the theorem. Listen carefully. The altitude to the hypotenuse of a right triangle is the mean proportional between the segments of the hypotenuse. Doesn't that sound like Greek? Well, let's take a look at the triangle and see what the words mean. Now this theorem sounds complicated, mainly because of the words that are in bold print. The altitude to the hypotenuse of the right triangle is the mean proportional between the segments of the hypotenuse. That'll clear up as we take a look at those words and the triangle itself. A right triangle is a triangle that has a 90-degree angle, a right angle. And that's indicated with a little square in the corner. The altitude is a line drawn from a vertex perpendicular, that is 90 degrees, to the side opposite. Here's the altitude. We'll call it A, but actually it's more than just a name, it's the length of the altitude. That altitude is drawn to the hypotenuse of the triangle. The hypotenuse is the longest side of a right triangle, the side opposite the 90-degree angle, the largest angle. So now we have the hypotenuse and the altitude. The altitude divides the hypotenuse into two segments. Segment X, more than just a name, it's the length of that segment, and this is Y units long, the segment Y. So already the meaning of the words is starting to come into shape. The altitude to the hypotenuse is the mean proportion between the segments of the hypotenuse. All that's left to clear up is the mean proportional.
Before we talk about the mean proportion, let's talk about proportions in general. Mathematics is not only a language, it's a foundational language. You learn some things before others. In the course preceding the geometry course, you would have studied proportions. Proportion is simply two equal fractions. 1/2 is equal to 4/8. We call those fractions ratios, and we read them 1 is to 2 as 4 is to 8. There are 4 terms, 1, 2, 3, 4 terms. The first term and the last term are the extremes. The 2 middle terms are the means. This theorem talks about the mean proportional. That's when these 2 mean terms are the same. So let's take a look at that. If one ratio is 1 to 2 and the other equal ratio is 2 to 4, both of the means are alike. Then we say that is the mean proportional between the other 2 terms. 2 is the mean proportional between 1 and 4. Now back to our triangle. It'll make sense because we have 2 equal ratios. The length of altitude A is the mean terms, both mean terms. One segment is x units long, the other segment is y units long, and the length of A is the mean proportional between the segments of the hypotenuse. Now, that helps on understanding the theorem. The altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse.
Okay, now that we have some understanding of what the words mean, don't you agree that the statement that sounded like Greek before now makes more sense? Don't stop learning math without considerable thought. Once you stop learning math, you have just closed and securely locked many doors to great career opportunities. The more proficient you are in math, the more of those career doors are going to be open for you to just walk through. Thanks for listening, and we'll be together again sometime and talk about the rules.